So, I have a question for you to start us off today.
All right, shoot.
When you think of the absolute most stressful job in the world, what immediately comes to mind for you? Like an air traffic controller, maybe?
Yeah.
Or a bomb disposal expert?
Oh, wow.
Yeah.
I'd probably say something involving really high stakes and very little room for error. Maybe a neurosurgeon, or honestly, just a kindergarten teacher on a rainy day when recess is canceled.
Yeah, those are valid choices.
Yeah.
Very valid. But after spending the last few days with our source material for you guys listening today, I am thoroughly convinced the answer is actually chili farmer.
A chili farmer. That seems distinctively lower stakes than bomb disposal.
You would think that.
Yeah.
But consider this right. You are managing a biological factory that is constantly screaming at you, but in a language you don't speak at all.
Okay, that's an interesting way to put it.
Yeah, because if you give it too much water, it drowns. Too little, it burns. If the air is too hot, it just drops its flowers. And if the soil is too acidic, it basically goes on a hunger strike. And you have to guess which one of these problems is actually happening, usually by just staring at a drooping leaf and hoping for the best.
That is a very dramatic, but actually quite an accurate description of the reactive trap. You're describing agriculture as it has been done for basically 10,000 years.
Exactly.
You see a symptom, you panic, and you react. And usually it's too late.
And that is exactly the frustration I ran into last summer on my balcony. I tried to grow these fancy habaneros.
Oh, nice. How did that go?
Terrible. They looked great at first, and then they looked sad, so I watered them, and they just looked sadder. It was a complete guessing game. Which actually brings us to today's focus. For everyone joining us, we are doing a deep dive into a document titled The Favorite Insight Framework for Smart Chili Fertigation.
Quite the mouthful.
It is a massive mouthful.
Yeah.
But stripped of the jargon, this isn't just a manual for growing spicy peppers.
No, definitely not.
It is a blueprint for stopping the guessing game.
Right.
It's a guide on how to take a chaotic biological process and turn it into a streamlined, data-driven machine.
Yeah.
And the core concept we need to talk about here is fertigation.
Right. Fertigation, which is a portmanteau of fertilization and irrigation.
Which sounds super efficient, right? Doing two things at once. But the text implies it's actually double the trouble if you get it wrong.
It absolutely is. Because you aren't just watering the plants, you are delivering their food through the water, so the stakes are way higher.
Yeah, that makes sense.
If you mess up the irrigation schedule, you aren't just dehydrating the plant, you're starving it. Or worse, you're hitting it with a toxic level of nutrients that it just can't process.
Oh, wow.
Yeah, you can chemically burn the entire root system in an afternoon if the mix is wrong.
So the source material lays out a solution for all this. It's not just buy this sensor or download this new app. It is a 6-layer framework from layer 0 to layer 5. And it's designed to take a farm from just pure intent to automated action. And I really want to walk through these layers with you because they completely changed how I view the concept of smart farming.
It's a really great structure, and frankly, it's applicable way beyond just chilies. It's a framework for decision-making in any complex system.
Let's start right at the bottom then. Layer 0, intent and context. This feels almost philosophical to me. The document says before deploying any device, the farm must clearly define its objectives.
It does feel philosophical, but it's actually the single most practical step that people skip.
Really?
Oh, yeah. In the tech world, we call this solutionism. You buy a gadget because it's shiny and cool, and then you try to find a problem for it to solve.
I am definitely guilty of that. I'm like, look at this wifey connected moisture meter. I absolutely need it. And then it just sits in the box in my garage.
Right, we all do it. But layer 0 asks why. What is the specific operational pain point you are trying to fix? The text lists examples like inconsistent yield or nutrient imbalance or maybe just really high water costs. You have to define what success actually looks like in hard numbers before you buy a single wire.
The text also mentions defining optimal growth conditions. That really caught my eye. It's not just, I want big peppers. It's way more specific than that.
Oh, it's about granular specificity. You need to define the risk thresholds.
What does that mean exactly?
For example, a chili plant might be totally fine at 30 degrees Celsius, but at 32 degrees, if the humidity drops below 60%, the flowers fall off.
Oh, wow. So it's a very specific trigger.
Exactly. That's a specific biological trigger. Layer 0 is about writing that rule down. You are defining the actual boundaries of safety for the crop.
It's kind of like building a house. Layer 0 is the architect's blueprint.
Yeah.
If you skip it and just start buying bricks, you end up with a complete mess.
Precisely. You determine the thresholds. Like if soil moisture drops below 18%, that is a critical risk.
Right.
If you don't have layer 0, you're really just hoarding data. You'll have a hard drive full of temperature readings, but you won't know which ones actually matter. You won't know the difference between warm and dangerous.
Okay, so we have our intent. We know we want to stop the flower drop and prevent nutrient waste, for example. We have our blueprints. Now we go shopping. Layer 1, the data foundation.
Yes, this is capturing farm reality. It's the hardware layer.
The source lists a specific cocktail of sensors required for chili fertigation. And it's not enough to just measure one thing. You need a complete picture.
You really do.
Obviously, we have soil moisture sensors. That's the basics. But then it gets into the chemistry set. EC sensors and pH sensors.
And this is exactly where most amateur smart farms, and honestly even some commercial ones, completely fail.
How so?
They measure water volume, but they completely ignore the chemistry.
Let's break that down because I think this is where the expert part of your title comes in handy for us. EC stands for electrical conductivity.
Yeah.
Why on earth are we measuring how well the dirt conducts electricity? I always thought water and electricity were a terrible mix.
In your bathtub, yes, absolutely. But in the soil, it's vital. Think of it this way. Pure distilled water is actually a terrible conductor of electricity. It's an insulator.
Okay.
But if you add salt to it, it conducts very well.
Right. I remember that from science class.
Well, fertilizers like nitrogen, phosphorus, potassium, they are chemically salts. When they dissolve, they become ions.
Oh, I see where this is going.
Yeah, so by measuring the conductivity of the soil water, you are getting a direct proxy for how much fertilizer is sitting there available for the plant to eat.
That is fascinating. So a high EC reading means lots of food, and a low EC reading means the pantry is empty.
Generally, yes, it tells you the concentration of nutrients. But here is the real kicker, and this is why you can't just rely on EC alone.
Okay.
You can have high EC, meaning plenty of food, but if the pH is wrong, the plant effectively starves to death while sitting at a fully stocked banquet table.
That's the nutrient lockout concept the text mentions later, right?
Yeah, exactly. pH measures acidity or alkalinity. If the soil is too acidic or too alkaline, chemical bonds form that literally lock up the nutrients.
So the roots physically cannot absorb the ions.
Correct. The food is there, but the door is locked.
Wow.
So you need both sensors. If you only look at EC, you might look at your dashboard and think, oh, they have plenty of fertilizer. But you walk out to the greenhouse and the plant is yellow and dying.
And if you don't check the pH, you might actually dump more fertilizer on it.
Which raises the salinity, burns the roots, and makes everything infinitely worse.
That explains so much about my failed gardening attempts on the balcony. I was probably locking out the nutrients without even knowing it.
It is the most common mistake. Layer 1 ensures you have the eyes to see both the quantity of food through the EC and the availability of food through the pH.
So layer 1 is really about gathering trusted data. The source makes a really big deal about secure telemetry and time series data. That sounds like a lot of IT jargon,
What?
but I assume it's crucial.
It is crucial. Time series just means the data is plotted on a timeline. You aren't just seeing the current temperature.
Right.
You are seeing the temperature every 15 minutes for the last month. That history is what allows for the insights we get in the later layers.
And what about the trusted part?
Trusted is key because if your sensors are cheap and drifty, or if your wifey keeps cutting out your expensive, AI is just going to give you bad advice much faster.
Garbage in, garbage out.
Always. You cannot build a smart system on a dumb foundation.
All right, so moving up the stack here. We have our goal in layer 0. We have our reliable hardware, sensing the chemistry in layer 1. Now we hit layer 2, which is descriptive insights.
This is the what is happening right now layer. This is all about visibility.
The text uses the term situational awareness. It kind of reminds me of a military operations room.
That's exactly the goal.
Yeah.
Imagine you are managing a large farm. You have 3 greenhouses, an open field, and a nursery. You physically cannot be in all those places at once.
No, definitely not.
If a pipe bursts in greenhouse 3, how long until you notice?
For me, usually when I walk in and see a massive flood.
Right. Layer 2 gives you a dashboard. You look at a screen and you see the heartbeat of the entire operation. You see real-time monitoring of soil, moisture, ECPH, and tank levels.
The examples they give in the deep dive source are things like spotting an overwatering pattern or seeing a temperature spike.
It's about replacing physical patrols with continuous monitoring. Instead of walking the rows to see if the soil looks dry, which is totally subjective, by the way, because the surface might look dry while the roots are soaking wet, you just see a line on a graph.
So it completely removes the human bias. I might feel like I haven't watered in a while, but the sensor says, no, the soil is still at 60% capacity.
Exactly. It anchors your decisions in reality, not your intuition.
But seeing the line on the graph is only the first step. That just tells you what happened.
Yeah.
Layer 3, which is diagnostic insights, is where it gets really interesting to me. This is the Y layer.
This is my favorite layer by far because it moves from observation to detective work. The core concept here is cross-sensor correlation.
Which is really just a fancy way of saying connecting the dots.
Pretty much. In a biological system, nothing happens in isolation. Let's go back to that nutrient lockout example from earlier.
Okay, yeah, walk me through the detective story.
So layer 2, the descriptive layer, alerts you and says, yield is down, the plants are growing slowly. That's the symptom.
Yeah.
If you stop there as a traditional farmer, you might panic. You might think it's a pest or a new disease or maybe a lack of water.
You just start throwing solutions at the wall to see what sticks.
Exactly. But layer 3, the diagnostic layer, looks at all the correlations. It queries the data. It sees that growth is slow and EC is high and pH is low. It triangulates those 3 facts.
And it rules out water.
It rules out water because the moisture sensors are reading normal.
Yeah.
It rules out lack of fertilizer because EC is high.
Wow.
It points the finger solely at pH. The system diagnoses the root cause. It tells you the problem isn't a lack of food. The problem is the acidity.
That is a huge distinction.
Yeah.
It saves you from making the absolute wrong move and ruining the crop.
Another great example from the text is identifying uneven growth. Layer 3 might correlate that with inconsistent moisture distribution.
How does it do that?
It looks at the pressure sensors and the flow meters in the pipes. It might realize that every single time Zone 4 gets watered, the pressure drops significantly in Zone 5.
Ah, so it identifies a clogged line or a broken pump rather than a biological plant issue.
Exactly. It turns the farmer into a systems troubleshooter rather than a biological guesser. You stop treating symptoms and you start fixing the actual causes.
Okay, so we've thoroughly explained the past and the present, but layer 4 is where we start looking into the crystal ball predictive insights.
Yes, the minority report layer.
Hopefully with less crime involved. But the text talks about forecasting soil moisture depletion rates. This kind of blew my mind a little bit. It's not just waiting for the soil to get dry, it's calculating exactly when it will get dry.
That is the real game changer here. Think about how we usually water plants. We wait until the sensor hits a trigger, say 10% moisture, then the sprinklers turn on.
Right, that seems totally logical.
It is logical, but it's fundamentally reactive. Because in that window between, say, 12% and 10% as it approaches that dry point, the plant might already be feeling stress.
Right.
It might have closed its stomata. Those are the little pores on the leaves just to save water.
And when it closes the pores, it stops eating carbon dioxide.
Exactly. It
Yeah.
stops growing, even if it's just for an hour.
Wow.
But layer 4 takes the weather forecast, like it knows it's going to be 35 degrees today, and it takes the plant's current size, and it calculates based on this heat and this wind, the soil will hit critical dryness at 2 p.m.
So you just water at 1:30 p.m. instead.
Exactly. You water before the stress signal is ever even sent. You maintain a perfectly flat line of optimal conditions.
The document mentions predicting heat stress too.
Same exact principle. If you know a heat wave is coming in 3 hours, you don't wait for the greenhouse to get hot. You predict the spike and turn on the misting fans now to lower the ambient temperature before it ever reaches the danger zone.
You are preventing the problem from ever existing in the first place.
You are.
It fundamentally changes the relationship with the plant. You aren't fixing it. You're nurturing it proactively. You're clearing the path for it.
You are optimizing its environment. You're removing the hurdles before the plant even sees them. And that logically leads us to the final stage. Layer 5, which is prescriptive insights.
The action layer. This is where the robots take over.
Well, yes and no.
This is where the system decides what to do based on all those incredible predictions we just talked about.
The text talks about rule-based automation, so activating pumps, dosing nutrients automatically.
Right. But there's a very important nuance here called controlled escalation. The source material is very careful to point out that the human is still in the loop.
Why is that, though? If the system is so smart, why not let it just run the farm while I go sit on a beach somewhere?
Because agricultural systems are incredibly high risk. Imagine a sensor malfunctions. A moisture sensor gets chewed on by a rat and thinks the soil is bone dry when it's actually a swamp.
Oh, no. Yeah, if you have fully autonomous automation without any human checks, The system might dump 10,000 gallons of water on the field.
Drowning the entire crop and bankrupting you on the water bill in one afternoon.
Exactly. So layer 5 often works on recommendations. It sends an alert to your phone saying, predicted heat stress in zone 1, recommend activating misting system, approve.
So it's kind of like an autopilot on a commercial plane. It handles the minute-by-minute stuff, keeping the plane level, but the pilot still has to confirm the big changes like changing altitude or actually landing.
Precisely. And it also tracks something called action logging. Every time a pump turns on or a nutrient dose changes, it's recorded permanently. This is crucial for compliance.
Compliance, you mean like legal stuff?
Absolutely. In modern farming, depending on where you are, you often have to prove you aren't polluting the groundwater with excess nitrates.
Oh, I didn't even think of that.
Or if you're selling to a premium market, you might need to prove sustainable water usage. Layer 5 gives you an automated bulletproof logbook of every single drop of water and a gram of fertilizer you ever used.
Which really brings us to the big so. What of all this? We've built this incredible 6-layer machine. We have sensors, we have AI, we have predictive automation. But is it really worth it? Growing chilies is hard work, but is it this complicated? Do we really need all this tech just for a jalapeno?
The source outlines several strategic values that argue, yes, it absolutely is. And it's not just about cool gadgetry, it's fundamentally about economics.
The first one that really stood out to me in the reading was nutrient wastage.
Yeah.
Fertilizer is expensive, like really expensive.
And the price fluctuates wildly with global energy prices.
Right.
If you can use 20% less fertilizer by targeting it, precisely using that EC and pH data to ensure the plant actually eats it, that goes straight to your bottom line, you are saving real money every single day.
And then there's irrigation inefficiency.
Water is becoming a scarce resource everywhere. Overwatering isn't just bad for the plant, it's expensive, and in some places it's literally illegal if you exceed your quota.
Then there's climate exposure. We touched on this, but with the weather getting weirder, more extreme heat spikes, unpredictable rains, this system acts like an insurance policy, doesn't it?
It creates vital resilience. If you are farming the old-fashioned way, a sudden heat wave just catches you off guard. You might lose 30% of your crop in one afternoon.
Wow.
But with Layer 4 predictive insights, you weather the storm. You lose nothing. That stability is what turns a volatile farm into a reliable business.
The text also heavily mentions multi-zone visibility, this idea that you can scale the operation.
That is huge for cooperatives. The source specifically calls out agritech integrators and cooperatives as the target audience for this framework.
Right.
If you are managing 50 small farms, you physically can't visit them all. But with this framework, you can monitor 50 farms from one single office.
It kind of democratizes the expertise. You don't need 50 soil scientists. You just need one system and 50 farmers executing the plan.
It completely raises the floor of quality. Everyone gets the benefit of the master gardener intelligence built right into the system. Yeah.
You can see exactly which farmer is struggling with pH balance in Zone 6 and send help exactly where it's needed, rather than just driving around aimlessly checking on people.
You know, looking at this whole framework from intent all the way to action, it really feels like we are watching agriculture transition into manufacturing. It's becoming true precision agriculture.
It is. But it also feels like something else to me. We are finally giving the plant a voice.
That is a really beautiful way to put it.
I mean, think about it. For the entirety of human history, the plant has been totally silent.
Yeah.
We had to guess what it wanted.
Yeah.
Are you thirsty? Are you hungry? Why are your leaves yellow?
And now?
Now, through telemetry, the plant is effectively texting us. It's saying, I need 5 milligrams of nitrogen, and I need it in exactly 20 minutes because the sun is coming out.
It is communicating. And that leads to a pretty provocative thought about the future of the farmer for you listeners to chew on.
What's that?
Well, if the plant can tell us exactly what it needs, and the system can predict the weather and automate the delivery, what is the farmer actually doing?
Yeah.
Hopefully drinking a nice cold lemonade on the porch.
Ideally. But seriously, it completely changes the job description.
It does. The farmer isn't just a physical laborer anymore. They aren't just hauling hoses and digging in the dirt. They become a data analyst. They become a strategy manager.
They are the CEO of the biological factory.
Exactly. They are monitoring the dashboard, they're tweaking the risk thresholds from layer 0, and they are making the high-level operational decisions.
Yeah.
It requires a completely different skill set. We aren't just growing better chilies, we are growing a completely different kind of farmer.
That is a wild thought. The farmer of the future might need to know Python code just as much as they need to know how to prune a branch.
Or at the very least, they need to know how to read a time series graph. That is the new literacy of modern agriculture.
Well, considering my balcony peppers died a tragic death because I didn't know how to read a simple leaf, I think I have some serious upskilling to do before I try again.
I'd say start with layer 0. Define your intent first.
I will. My intent is do not kill the plant. I'll write it down in big letters and stick it to the pot.
It's a very solid place to start.
Thanks for walking us through this deep dive. It's truly fascinating to see how deep the rabbit hole goes just for a single chili pepper.
It is never just a pepper, it's a data point.
And to you listening, thanks so much for tuning in. Hopefully this gives you a brand new appreciation for the technology sitting behind, or I guess underneath, your food. Maybe it even inspires your next garden project. Just remember to define your risk thresholds first. Catch you in the next deep dive.